Okay, we're going to simplify these complex fractions, which means we've got these fractions on top of other fractions and we're sort of dividing them, but what you're going to do is look at all your denominators. So in this case, we've got these denominators of a 4 and an 8 and a 12, and remember, any whole number is always over 1. So we've got the numbers 4, 8, 12, and 1, which we don't really have to work with on that. So we want to think about what would be the common denominator between all of these. And remember, like if you had, 2/3, and you're adding 3/5, then you're looking for that common denominator between like 3 and 5, which would be 15, the two of them multiplied together. And so we just want to come up with the multiples of all of these denominators that are in this complex fraction and see what the common denominator would be. So in this case, 4, 8, 12, 16, 20, 24, which I think 24 will be it, but 8, 16, 24, then 12 and 24, and we know 24 would also be a factor of 1. So 24 is our common denominator. And what you want to do, remember then, if we took, say we went like 2/3, and I'm still just sort of using this as a little example just to remind us of the simpler versions of things, but 2/3 times 15. Remember that we could always come and reduce these fractions. So 15 divided by 3 leaves us with a 5, and that would be 2 times 5 then is 10. And that's the concept that we want to do with these complex fractions, is to try to get rid of all these denominators. Or if you had a, addition type problem that had all these fractions in it, sometimes we would multiply through by that common denominator just to get rid of all the fractions. So that's basically the same concept that we're going to do here. We're going to multiply each one of these terms by this common denominator of 24. So we've got 3/4, and we're going to multiply it times 24. Remember, any whole number is always over 1. Then minus 1/8. And we're going to multiply it by 24. Okay, then we're going to take this 2, which is 2/1, times 24. Add 1/12 and multiply it by 24. Okay, so we're multiplying each one of the terms in our original problem by that common denominator of 24. Now, here's where we want to try to reduce. So here we can reduce this 24 with this 4, and that becomes a 6. Well, 3 times 6 then is 18. Anything over 1 is always just the number. Remember that. Okay, so the 8 in the 24 will reduce to a 3. So 1 times 3 is 3. And we do the same on the bottom. Well, this 2/1 times 24/1 doesn't reduce, but 2 times 24 is 48. Now here, the 12 in the 24 reduce to a 2, and 1 times 2 is just 2. So same exact spot here. This became the 18, this became the 3, the bottom first one became the 48, and this became the 2. Now we're just going to do our addition and subtraction on our numerators and denominators. So 18 minus 3 is 15, and 48 plus 2 is 50, And remember, you always want to reduce that. So 15 over 50 is reduced by 5, and that gives us 3 over 10. Okay, so in this example, we have a denominator of x plus 2, and we have a denominator of x. Well, then that will never have a multiple, so we're just going to say that common denominator is x times x plus 2. So we've got this 1 over the x plus 2, and we're going to multiply it times x plus 2, and that's all over 1. Then we have the 6, and we're going to over 1, and we're going to multiply it times x plus 2. Then we're going to add 4 over x, and we're multiplying that x times x plus 2 all over 1. So remember, again, each term just got multiplied by that common denominator of x times x plus 2. Well, in this case, this x plus 2 cancels out, so 1 plus x is just, or 1 times x is just x. And you see how we got all those denominators up here are all over 1, so anything over 1 is just itself. All right, so this 6 over 1 times x plus 2, and we're going to multiply that out. So let's see, it needs everything, so it's going to be 6x times that x plus 2, which gives us 6x squared plus 12x. Now on our last term, our x's will cancel out, and that leaves us with the 4 times the x plus 2, which is 4x plus 8. Okay, so that denominator became a little bit long, but we're still going to add any like terms that we have. So that gives us x over 6x squared, and we've got the 12x and the 4x, which makes 16x plus the 8. Okay, so that is a totally acceptable answer because we know we can't reduce anymore from that. But if you wanted to factor out the 2 on the bottom, you could say x over 2, factor out a 2 from the 6, the 16, and the 8, and that would give us 3x squared plus 8x plus 4. And that would be your final answer. Okay, so on number 3, we've got all these denominators. We've got an x, we have a 2x, we have a 3x, and a 4x. Well, they have these x's in common, so we know that that common denominator is going to include an x, but then we've got to look for the numbers. What's a common denominator between 2, 3, and 4? Well, I think that would be 12. So that will give us 12x as our common denominator. We're going to multiply each term then by that 12x. So 1 over x times 12x plus 3 over 2x times that 12x. All over 1 over 3x times the 12x plus 3 over 4x times the 12x. Okay, so now let's go back. Let's look at each term and let's reduce what we can. So in this first one, our x's will reduce to a 1. So 1 times 12 is just 12. And that is that first term. Now the 3 over the 2x times the 12x, well, the 2x and the 12x will reduce to a 6x. No x, sorry. Just 6. The 12 and the 2 reduce to a 6, and the x's will cancel them out. So then 3 times 6 is 18. So now next term, first term on the bottom, the 3x and the 12x, that will reduce to a, let's see, the 3 and the 12 reduce to a 4, and then the x's will reduce. So 1 times the 4 is just 4. And now on our last term, the 4x and the 12x will reduce to a 3. 12 divided by 4 is 3, and then the x's cancel, so those go away or reduce with each other, and 3 times 3 is 9. Okay, so all we have to do is our addition here. So we've got 12 plus 18, that gives us 30. 4 plus 9 is 13. Don't think that can reduce, so that is your final answer. Okay, so last example, our common denominator here. Remember, x squared minus 1 factors into x plus 1, x minus 1. These are all over 1, so that common denominator is your x plus 1, x minus 1. Okay, so every term is going to get multiplied by that x plus 1, x minus 1. All right, so we've got our 1. We're going to multiply it by our common denominator, x plus 1, x minus 1, plus the 1 over x minus 1 is going to get multiplied by x plus 1, x minus 1. Remember, that's always over 1, as is all this. Then, whoops, it should be in blue. Okay, again, we've got that 1. And don't forget to always multiply even those whole numbers by that x plus 1, x minus 1, or whatever your common denominator is. Plus 1 over, remember that x squared minus 1 factors into x plus 1, x minus 1. And then we are multiplying it by x plus 1, x minus 1. Okay, so we don't have anything on the first one that reduces, so that is still going to be x plus 1, x minus 1. But I'm going to go ahead and multiply that out. We know that's x squared minus 1. Now, on our second term, we have our x minus 1s will reduce, leaving us with this 1 times the x plus 1. So that is just plus x plus 1. So this term again is going to be that x squared minus 1. And this actually gets to reduce. X plus 1s, x minus 1s cancel out, leaving us with just 1. So that will be plus 1. So if we have let's combine like terms. On the top, we've got that x squared. We have a positive x, and then the negative 1 and the positive 1 will cancel out or make 0. And so that is going to be all over x squared. Well, I see on the top that both terms have an x, so I can factor out that x, and that would leave me with x plus 1 all over an x squared, which remember is x times x. So this x, those will reduce with each other to 1, leaving us with the final answer of, I'm going to come over here, x plus 1 over x. Okay, hopefully you sort of understand that. Just be sure to ask me any questions if you have any.